Consider this example, the example which we have considered earlier, example 1. That means we have two places, place P on, the other place P off. Initially, two tokens in the place P on, no token in the place P off. Therefore, the marking will be a 2 tuple. Number of tokens in each place form a marking. Therefore, the first place is P on, second place is P off. With that assumption, suppose the first place is P on, second place is P off, then the number of tokens at time 0 is 2, 0. After T failure firings, the marking will be 1, 1. Again the T failure firing, the marking will be 0, 2. From 1, 1, if T repair fires, then the marking will be 2, 0. From 0, 2, if T repair fires, then the marking will be 1, 1. Hence, the marking is the m tuple, number of tokens in the place I at any given instant of time, and the marking is reachable whenever some sequence of a transition fires, and the reachability graph is a directed graph whose nodes are the markings in the reachability set, with directed arcs between the markings represent the marking to marking transitions. Hence, in the same example, the markings are 2, 0, 1, 1, 0, 2. The marking can be reachable from 2, 0 to 1, 1 by the transition T failure fires. The marking 1, 1 is reachable to the marking 0, 2 with the T failure firing. The marking 0, 2 is reachable to the state to the marking 1, 1 by T repair fires. Similarly, 1, 1 to 2, 0 by firing T repair transition. So, this is called a reachability graph. Now, we are moving extensions, arc extensions in Petri net. Till now, we have considered very simple Petri nets. Now, we are going for arc extensions. Both input and output arcs in the Petri net are assigned a weight or multiplicity or cardinality, which is a natural number. If the multiplicity of an arc is not specified, then it is taken to be unity. So, in the previous examples, we have considered as a multiplicity is unity. The next extension in the Petri net is a inhibitor arc. An inhibitor arc drawn from place to the transition means that a transition cannot fire if the corresponding inhibitor place contains at least as many tokens as the cardinality of the corresponding inhibitor arc. Usually, input arc and output arcs makes a transition enabling and firing, removing the tokens, depositing the tokens with the multiplicity or cardinality. But the inhibitor arc drawn from place to the transition means that the transition cannot fire if the corresponding inhibitor place contains at least as many tokens as the cardinality of corresponding inhibitor arc. If there exists an inhibitor arc with the multiplicity n between a place and a transition, and if the place has n or more tokens, then the transition is inhibited even if it is enabled. The transition can enable based on the conditions through the input aux. But if there is an inhibitor arc, then it may be inhibited based on the number of tokens in the corresponding input place. Input aux are represented graphically as an arc ending in a small circle at the transition instead of arrowhead. Usually input aux as well as output aux drawn with a arrowhead, but inhibitor aux are represented graphically as an arc ending in a small circle. We will see the example in this slide. In this example, we have 3 places P1, P2, P3. We have one transition, one input arc, one output arc, one inhibitor arc. Here, whenever the number is written next to the aux, that means the multiplicity or cardinality of the output arc is number 3. If there is no number, natural number written next to the aux, that means the default multiplicity is 1. Here also the default multiplicity is 1. That means if one or more token in the place P1, even the transition is enabled by the condition through the input aux for this place input place, this transition may not fire if one or more tokens in the place P1. So, here no token in the place P1, whereas one token in the place P2, no token in the place P3. Hence, the transition enables and then fires by removing one token in the place P2 and one token deposited in the place P3. Only the tokens will be removed from all the input places which are connected, the places connected with the input aux to the transition, and the tokens will be deposited to the all the output places which are connected from transition to places through output aux. So, in this example, after the transition fires, no token in the place P1, no token in the place P2 and 3 tokens in the place P3, because the multiplicity of the output arc is 3. So, even though one token is removed from the place P2, because the multiplicity of the output arc is 3, hence 3 tokens will be, multiplicity is 3, therefore 3 tokens will be deposited at same time in the place P3. Now, we are moving into the extension of Petri nets into stochastic Petri nets. Petri nets are extended by associating time with the firing of transitions, resulting in timed Petri net. A special case of timed Petri nets is stochastic Petri nets, in other words SPN, where the firing times are exponential distributed. Exponential distribution. So, whenever the firing times of all transitions are exponential distribution, then the corresponding timed Petri nets are called stochastic Petri nets. Every Petri net one can get the reachability graph. The underlying reachability graph of an stochastic Petri net is isomorphic to a continuous time Markov chain. For a stochastic Petri net, the underlying reachability graph is isomorphic to a continuous time Markov chain. Let us see through the examples. When two molecules of hydrogen is combined with one molecule of oxygen, then two molecules of water is formed. The balance equation is written. The balanced chemical equation is given by 2H2 plus O2 gives 2 times H2O2. So, this is the balanced chemical equation. For this scenario, we have made 3 places: P hydrogen, P oxygen, P water, and we have one transition that is called a T reaction. The multiplicity of a input arc from the place P hydrogen to the T transition, that is 2, whereas the multiplicity of the arc from P oxygen to the T reaction, that is 1, whereas the multiplicity of a output arc from the transition to the place P water, that is 2. On firing of the transition T reaction, two tokens, because the multiplicity is 2 tokens will be removed from the place P hydrogen. The multiplicity is 1, therefore 1 token will be removed from the place P oxygen. Since it is a rectangle bar, that means the timed transition follows the time of a timed transition follows exponential distribution. So, after two tokens will be removed from the place P hydrogen, 1 token will be removed from the place P oxygen. On firing of the reaction T reaction, 2 tokens will be deposited in the place P water, because the multiplicity is 2. And here we made the assumption the reaction time is a exponential distribution. Hence, we made a stochastic Petri net and we make the model using stochastic Petri net of this chemical reaction.